Okay, share my screen. Go. All right. So without further ado, this will be a intro level talk on programming with classes and objects in Python. My name is Toshio Kuratomi, and I'll walk you through just a few basics here. This talk isn't going to be, very comprehensive, but these are the things that I hope you'll get out of it. By the end, I hope that you'll be able to recognize the parts of a class. So if you're reading someone else's code and they're using classes and objects in order to do their work, hopefully you'll be able to read it, understand what they're doing, and be able to know enough about it that you'll be able to understand how you might need to change their code in order to make it work the way you want it to. By the end of this, you should be able to write a basic class. It might not be, the end-all be-all class that can do everything, but you should be able to start to make use of them and start to explore on your own. I will show you some patterns for advanced features. The idea there will just be that when you're out looking to do something new, you'll have some understanding of, can I even do this at all? And have an idea of what you might be able to search for in Google in order to, get more information, the documentation and so forth for that. If we have time, I'll try and include a little bit of information on best practices. Why would I use a class? When would I not use a class? Things like that. So let's start with the parts of a class. Here's a very simple sample class. It kind of models what some of the important things that I might need to know about a person inside of a program. The first line is called the class definition. As you can see, it starts with the class keyword. The class keyword is what tells Python that we're going to be dealing with a class. The second thing that you see is the class name. In Python, we usually, by convention, we capitalize every word in there. So person, just one word. The P that starts that word is capitalized. The next thing on the line is a list of parent classes. So classes can do something called inheritance, where there's a parent class that implements some features of the class, and then you create a child class, subclass also called, which inherits from the parent class certain attributes, certain methods, certain ways of doing things. That way, you don't have to rewrite every single thing that your class does if you already have another class that does part of the work that you need. In this case, we're inheriting from object. Object is the root class of every class in Python. On Python 3, you don't have to specifically explicitly specify object. If you just put person and then the colon, Python 3 will know what to do. But if you're dealing with Python 2, you'll want to put the parentheses and object or another parent class in there. The next thing to notice are method definitions. If you look at these, they should look very much like function definitions to you, and that's because methods are just a type of function. What makes methods special is that they are bound to the class that they are a part of. If you look at these, they are all indented underneath the class declaration, and that tells Python that these are methods of the class, these belong to the person class, and it will, associate them together in ways that we'll see going forward. If you had another function after format name tag and it was outdented to the same level as class is, class person is, then that would no longer be a method of the class. That would be a standalone function. And, the indentation level is what tells Python whether it's going to belong to the class or you're starting a new block with a new function that's going to be separate. The other thing that you'll notice is that both of these methods have the self parameter as the first parameter. If you have had other object-oriented programming classes in like C++, for instance, this would be equivalent to the this variable. Self is only a convention for the name of this parameter. So, if you're coming from another language, you might be tempted to name this something else like this. I would encourage you not to do that. The convention in Python is to use the name self. If you use this, Python will not complain, but when other people read your code, they'll have to pause and they'll have to think, oh, why did they use this strange variable name for the first parameter? I don't know. Are they doing something different? And it'll just cause more problems for them, reading the code, trying to figure out what you're doing. Even if you're doing exactly the same thing here, just using a different name, it'll cause them, a mental burden having to read your code, having to think about it and figure out what you're doing. I want to explain more about what self is and what it does, but in order to do that, we need to take a brief diversions and talk about using classes and instantiating them. So a class itself is a blueprint for an object. It's not something that you use directly. It's like the plans for how to construct an object and what can be done with it. When you do something that we call instantiating, we make an instance of the actual structure that you can then use. So I'll take an example using an object from the standard library. Here we have names equals list, parentheses, Toshio, and Ernie. So you've probably used list before in your code. List is the constructor list is the name of the class as well. So in this example, we have list, a class, we have the parentheses, and we're calling that class with two parameters. What does it do? Since you've used list before, okay, well, that creates a list, an instance of list. It stores it into the names variable. And then in this for loop, I'm looping over the names that are in the list. It extracts one name each time, and then I print it. It's going to print Toshio and Ernie on two separate lines. Let's think about this as a class. Or usually you don't think of list as a class, probably. You think, oh, list is a function, right? It looks like a function call. I have list, parentheses, two parameters that I'm passing in. But it is really a class. And one way you can tell is by kind of experimenting with it and getting this error. So like I say, a list is a class is a blueprint. So we're going to take list, which is the class itself. We'll try and loop over that, right? Because, oh, you can loop over an instance of a list. Can you loop over the class itself? It turns out you can't, which is probably pretty expected. When we do the for item in list, print item, we get a traceback. And the traceback says type error. Type object is not iterable. All classes in Python are of type. And, well, that's not 100% true, but all the classes that you're going to encounter for the vast majority of your Python existence are of type. So when you see something like this, where it's a type error and saying that the object is of type, then oh, this is a class. It's not a function. That would be a function or callable object. This is a type object, so it's a class. If you were to write out the list class in Python, it would look a little bit like this. This isn't 100% correct because, list is actually implemented in Python's internals. So they have like a C version of it that's faster and so on and so forth. But if you're trying to write it in Python, it would look something like this. Has the class, keyword, just like we talked about. List is the name of the class. This one inherits from sequence, which is collections.abc.sequence. And sequence just defines the things that you generally think about when you have a class, right? It has the ability for you to iterate over it in a for loop. It has the ability to index it with 0, 1, 2, 3, and so forth in square brackets to get something out of it. So this is something that implements a sequence. Then we need to go ahead and implement those methods. So the under init method that we saw in the person classes here too, how we implement it will be a bit different, but it'll still be here. I'll go into what under init means and why we have them in almost every class. a little later. There's under iter. This is a special method, which is what allows you to do iteration, meaning being able to loop over it in a for loop, being able to loop over it in other instances. We have under get item. That's what does the square bracket notation. So when I'm doing, names, square bracket 0, and it returns Toshio, the under get item method is what's going to do that. And then we all know, there's list.append, list.extend. These are also methods of the class. Right. So let's take that idea of, what list might look like and apply it to this class person that we've already created. So person is the blueprint. In order to instantiate it, we call it as if it was a function. So here I have user equals person, parentheses, Toshio, comma, 1900, end parentheses. And so that creates an instance of the person class. Once I have that instance saved in user, I'm able to do things with it. And so here I'm doing print user.format name tag. Format name tag is that second method in the person class. And so when I call it, it's going to call format name tag on the instance. And so anything that was saved on that specific instance is going to be available to format namespace to use. As I get into what self means, I'll get into how that all works. So now we have the basis of understanding, what is this self variable? When you create an instance of the class by user equals person Toshio 1900, and you get the instance in user, you then have an object in memory that conforms to the structure of person, but it has its own memory locations for storing variables. For if you want to override a function at runtime by just assigning, the function name to some other function. If you want to do anything dynamic and store something inside of the class that isn't actually specified in the class itself, all of these things are things you can do on the instance, and then that specific instance will have those values. If you create a separate instance, so like if I had user2 equals person Ernie 1900, then any changes I make to user will not be reflected in user2 because they're two separate instances. Self is that instance of the class which Python automatically passes into each of these methods. So when you create the class, the under init method is called automatically by Python as part of creating the class, and it will create the instance. It'll allocate all the memory for it, and then it'll pass it in as this self parameter. And so then inside of the under init, we're creating an attribute self.name, and we're saving the name there, self.birth year, saving the birth year there. So that's being saved on the instance itself. In format name tag, you see when we call user.format name tag, we have an empty argument string. But when Python reads your code and executes it, it says, oh, user's that first part of, it's the instance that we're calling format name tag on, user.format name tag. Self is going to be user. And so throughout that code, whenever you see self, it's that user that we created, instantiated up above. It's kind of equivalent to this code here. So we had print user.format name tag with an empty parameter list. Python is sort of saying, okay, well, take the person class, find the format name tag method on that, and then call it with user as the parameter to that function. Now let's talk about under init. Under init is your first special method. You can tell it's a special method because it has 2 underscores before it and 2 underscores after it, right? That is a convention. It's not it's not required, but it's a convention that anytime you have a special method, something that Python is going to use, not just explicitly, like you have to call it explicitly, but for something behind the scenes to implement some special feature, it's going to have those double underscores before and after the main part of the name. What is under init specifically? It's similar to a constructor in other languages, but it's really just an initializer. And what do I mean by that? Well, if you're used to constructors in, say, Java or C++, let's take C++. The constructor is responsible for a whole lot of things. It has to allocate the memory for the person object. If you're creating self.name, it allocates the memory for that variable. Anything that's passed into it then gets assigned to the right variables. It's doing all of this work to actually bootstrap the object, to bring it up from nothing and create it. But with Python, it actually has a separate constructor which does the memory allocations and those sorts of things, deciding on the shape of the class. And then when you get to, and then right after that, it calls under init, and it passes that newly created, that newly instantiated object in, and then you're able to just initialize the variables that you want, the attributes that you want in your instance of the class. It's, as the bullet points say, it's called after memory is allocated, and it's just used to initialize the initial state of attributes. So most of the time, if you see an under init method, it'll be very simple like this. Once in a while, you have to actually call other functions in order to get some information. And so then it gets a little more complicated. But the basic idea is you're initializing the object. So you are going to make some function calls or set things from parameters or combine parameters together, whatever you need to do just to kind of set up the object for later use. Let's talk about attributes. So here we have two attributes, self.name and self.birthyear. Attributes are basically just variables that are set on an instance of the class. And by that I mean, okay, I have an instance, it's called user, and that user has two attributes. It has a name attribute, it has a birth year attribute that have been set. If I want to reference them, I'm going to go ahead and use dot notation. So user the instance, dot name, which is the attribute's name, right? And when I do that, I'll get back Toshio, because in my under init, I set self.name equals the name that I passed in. If you look at the instance person Toshio, Toshio is what was the name passed in. Now in Python, attributes are both readable and writable. This is not the same in all languages. Some languages, most languages allow you to say some attributes are writable and others are only readable. But Python's not like that. Python has this idea of consenting adults. We are going to document which things you're allowed to write to, and maybe we'll use a convention like an initial underscore. Like if it was self._birthyear, we'd say, oh, we don't actually want you to access this variable directly. We want you to access it only through the methods that we provide. But if you really do want to, it will happily let you, because it says, you know, consenting adults. If you think that you know better than me, who wrote this class, about what you want to do and need to do, you can go ahead and do it. I won't stop you from doing it. So in this case, you know, there's no documentation that says we shouldn't write to user.name afterwards. There's not a leading underscore, so convention isn't there to say, oh, give us a warning that, oh, maybe I shouldn't be doing this. So I'm going to go ahead and set user.name, that attribute, to Ernie now. And then when I print user.name, it's Ernie. So this is an attribute. It's just kind of a regular variable, except that it's set on an instance of the class. If I have user equals person Toshio 1900 and then user2 equals person Ernie 1900, those are two separate instances. If I change user2.name to equal Bert, the original user1, will still be Toshio. It's only user2 which will have had its name changed to Bert. Let's take a brief moment here and talk about some best practices. When you're setting attributes in your class, you really should initialize all of those attributes in under init. And here's some code that shows doing it the wrong way, and I'll explain why it's the wrong way. So here, you know, we've added a new method, set nickname, and it's setting a nickname attribute on the instance of the class. And okay, Python lets you do this. It's not going to complain, but it's bad practice. And why is it bad practice? Well, if we look in the format name tag method, we see that we're now using self.nickname in that method, right? Okay, well, what could go wrong? Let's say that I create an instance of the person class. I call, name user equals person Toshio 1900. Okay, now the name attribute has been initialized to Toshio. The birth year attribute has been initialized to 1900, but the nickname attribute doesn't exist in the class yet. It doesn't exist in that instance. It's not until I call set nickname that it will exist. So let's say I don't call set nickname. I just call person to instantiate it. And then right after it, I call format name tag. Well, Python will start running format name tag. It'll write name tag equals empty list, name tag dot append, my name is Toshio. And then it'll call name tag dot append, call me self.nickname. And it'll say, there's no self.nickname here. You haven't told me about self.nickname. I don't know what this is. It'll raise an exception because self.nickname doesn't exist yet. It's not until you call set nickname that exists. So this is a hidden thing that, the user of your class, someone else, not you, that programs with your class, might not know that set nickname has to be called first. It's not obvious. And so they can run into this problem of they are creating an instance of your class, they're calling a function, a method, and it will error out because it hasn't been initialized. There's two ways we can fix this. Both ways are, setting that nickname in the under init. This way that I'm showing you right here, we're just going to say, okay, well, I'm going to make the user pass in nickname at the beginning as well. So now when you instantiate person, you would have to call it with person, name, so like person Toshio 1900, nickname Tosh. And then when you get into under init, it'll set self.name equals Toshio, self.birth year equals 1900, self.nickname equals Tosh. And then you'd be able to know without a doubt that when you do format name tag, that will work. It won't trace back because you have a self.nickname defined. The other way is to say, well, I'm not going to require the user to pass in nickname, but I still need to set self.nickname in under init. So in that case, you can, not put nickname in the parameter list, but you can say self.nickname equals empty string, for instance. And that way you have set self.nickname to something, some value. It's just a value that hasn't been filled in yet. Then later, the person can say, oh, well, I really do have a nickname. I'll call self.nickname and set my nickname to something. And then when name tag.append is run, format name tag is run, it will use that new nickname that I've added. One further note, in Python, we don't usually have setters like this, like set nickname. Usually we just let people read from attributes directly and write to attributes directly, and we document if they aren't supposed to do that. But sometimes you are going to want a setter, and you're going to want it because you might need to do something. Like, let's say that every single nickname, you want it to be formatted with double quotes around it. So if you do that, then by creating a setter, you can then make it put the double quotes around it. However, as you can see, as I said before, Python doesn't prevent you from writing to the variable directly. So you're probably going to want to do some other things, write documentation that says don't set self.nickname directly, always use set nickname. You're probably going to make mark that as private just by convention, by making the attribute self._nickname, and then anyone who is trying to use your code and write to it, use it in their program, will say, oh, that's a private variable. I shouldn't be writing to it directly. Oh, look, there's a method here, set nickname, which is going to set it for me. I should use that instead. All right, let's talk about calling methods. We kind of went over this already, but let's make explicit what we've learned so far. These methods are really just functions when we call them. we're calling them just like we would normal functions. That self is being passed by Python in there. Python automatically creates it. So we have two functions and we've gone over calling them. Under init is invoked by Python itself. But really, when you think about it, this user equals person Toshio 1900, that maps very directly to calling under init yourself, right? You can see, oh, it needs 2 parameters, and I'm giving it 2 parameters. So you can just kind of think of it as calling person, the class, is equivalent to calling under init, the function. That mental model is almost correct. It'll get you through like 90% of all Python code that you're going to read. By the time you're dealing with other types of Python code, you're going to be more advanced. You're going to know what to look out for and how to look for the documentation for those more advanced features. And then the second thing we're doing here is calling the format name tag method. And like I said before, there's nothing in those parentheses because Python itself is binding self to the user, the instance, the class that you're calling it on. So pretty simple. Let's start going beyond the basics. So under init is a special method. We've talked about that. Let's talk about a few other special methods. So stir. Here we have, format name tag, and when we call it, we have to call it as a function explicitly user.format name tag and then the 2 parentheses. But I'm thinking, there's other classes in Python like the list class. I don't have to call list.format list for printing or something like that, right? I can just do print that list that I had. So how does it do it? It uses this under_stir method to do it. So what under_stir does is it says, okay, anytime I'm used in a string context, like print takes a string, so it needs the variable to be a string. If I get used in a format string with %s, various different things, I'm going to be converted into a string. This is the representation that I should have then. And so instead of calling it format underscore name tag, we're going to call it under_stir. So by making that method, that special name, print user will suddenly do what in our previous slide, format name tag would have done. It's going to do all of those same steps. It's just that how we write it when we call it is going to be different now. Why you might want to do this is because it gives you the ability to use this class in other ways than before. Print format string %s %user. Before, if we did that, it would print a computer kind of representation of person. It wouldn't be very good to read. But now we have this human readable representation that's easier for us to read. And now we can just use it in print, in format strings like this. We can use the stir constructor to create a string from our person, and it will call under_stir to implement that. So these are things that you might find yourself wanting to do in your code. If you implement, an under_stir special method, then you're going to be able to do that. I talked earlier about person by default is going to return something that's not really that readable to a human. Well, that's actually coming from repr. Repr stands for representation. Stir stands for string. String is the human readable version, string version of the class. Repr is more of a computer oriented version. By convention, if you're overwriting repr like we're doing here and creating a new one, then you want to be creating a string which looks like how you would call a person in order to instantiate a version that contained all the data that you have in it. So here you see I defined repr as returning a string person with Toshio in single quotes and then birth year off by as the second argument. And when it prints it, the repr looks a lot like the instantiation call, right? In this case, it looks identical to the instantiation call. That's your standard that you're trying to aim for. You want it to look like that. You won't always be able to because sometimes things will be more complex. but you're trying to aim for that. That's the goal. Here's under equal. It's another special method, and it defines equality. So here we're going to use under equal, and we're going to set, okay, it gets called with the instance of the object and another thing. Why is that? Well, think about the double equal sign, the comparison of two objects, right? You have something on the left-hand side and something on the right-hand side. So this is in other languages, this would be called operator overloading. We're overloading the double equal sign so that equality is going to run this function in order to check whether something is equal or not. And so by default, if you don't define under equal, Python will check and see if two things are the same instance of the object. So if I didn't define under equal, I said person 1 equals person Toshio 1900, person 2 equals person Toshio 1900. If I ask, is person 1 equal to person 1? Python would say true. You expect that. But if I said person 1 equal person 2, it would say false. And why? They have the same data, but they're different instances. And so that's why it would say false. Now, I don't want that behavior for person. I want, if it has the same data inside of it, I want them to be equal. So I'm implementing my own special method equal, under equal. And what that does is it says, okay, Python, if you see that I'm using person, an instance of person with the double equal sign to do a comparison, use my function instead. And in my function that I've defined here, I'm saying, okay, I'm going to compare self.name, birth year with the other name and other birth year. If those two things are both the same, then I'm going to return true. If they're false, it's one of those things is different, then it's going to return false. So then here are 3 prints, and they're going to print false, true, false. The first one is taking the ID of person 1, the ID of person 2. The ID relates to the instance itself, right? Each object that you instantiate has a new ID. So ID of person 1, ID of person 2 is going to be false. Just like if we didn't define under equal at all, it would be false. But then we print person 1 equals person 2. That's going to be true because the under equal that we implemented says if name and birth year are the same, then they'll be true. And when we instantiated person 1 and person 2, the name and the birth year were the same. But then the last one is person 1 equal to person 3. That will print false because you see when we instantiated person 3, we set the name equal to Ernie, the birth year equal to 1910. Neither of those are the same as what we set in person 1. So equality will be false in this case. All right, let's switch from special methods and let's talk about inheritance for a little while. Inheritance is basic to object-oriented programming. It allows you to not repeat yourself. So we have our person class, and let's say that we have several different types of persons. We have a person who is a teacher, we have a person who is a mechanic, we have a person who is a driver. And each of these are going to have all the same behaviors as person, but some additional things as well. Inheritance is for extending a base class. So here we have a class driver. It inherits from person. It lists person as its parent object. So that means it inherits from it. And it defines one method, is eligible. And what it's eligible is doing is is eligible for a driver's license, right? If the year today minus your birth year is greater than or equal to 18, then you're over age 18, you're over 18 years old, it's going to return true, you're eligible for a license, otherwise it will return false. So what happens when we use driver? Well, user equals driver, parentheses Toshio 1900, this is us instantiating it. What is it using to instantiate? There's no under init defined in the driver class. Well, because of inheritance, Python says, is there an under init in driver? No. Okay, what about in person? Yes, there's an under init there. Okay, we will use that as the under init. So we saw what person did before. It sets self.name equals Toshio, self.birth year equals 1900. Okay, now we call user.isEligible. Where's is eligible coming from? Well, driver itself implements is eligible, so that gets called. Self is bound to the instance of driver that we made, right? And then we go inside date.today.year minus self.birth year. Where does self.birth year come from? Because person is the parent class of driver. When we set those attributes, they're being set on this instance of driver. So this is just like, if we had written the driver class out and it included both the under and the under string, it would work just the same. So user.isEligible is going to return true because it's taking that birth year that we defined when we instantiate the class. It's finding that, okay, we're greater than or equal to 18, so it's going to return true. Then we do a print with formatting the user as a string, and it's going to call that under string from the person object, because once again, inheritance is saying, okay, I don't see under string in the driver class, so I'm going to look at the parents, and in person, the parent of driver, there's a string method, so I'm going to use that. Let's go one more thing, one more advanced topic that I can just get into here, and that's properties. So in Python, the easy way to define a property is with this decorator at property and putting it on a function, on a method of the class. But what is it doing and why would we want to use it? Well, if we look at isEligible here, this is a good candidate for a property. And the reason I say that is because it's just going to return one of two values, true or false. It's just going to return, a straight value. It's not really doing something that you expect to do a side effect. Like it's not saving to a database. It's not writing a file to the file system. It's just kind of calculating some data from the things that driver already knows about, the name, the birth year that you passed into it, and then that's returning true or false based on that. So you could kind of see yourself doing this ahead of time, right? Oh, I'm going to create a eligible attribute, and I'm going to calculate in date.today.year minus birth year, and is that greater than 18? Okay, then I'll say true in that attribute, and if it's false, then I'll say false on that attribute, and then I can just access it as user.eligible. So that works, and it's more convenient than is_eligible parentheses a little bit, right? And it kind of feels natural that it'd be an attribute. But the only problem is, what if this program that I use driver in runs for a long time and the year changes over, it's run for 2 years. All of a sudden, that value that I calculated once at the very first time I created driver, it would be wrong. So by using a property, you can get it to kind of to look like an attribute, but it'll be calculated dynamically when the attribute is used. So here I've renamed the function from isEligible to just eligible, and I've marked it with the property decorator. And now when I use user.eligible, looking like an attribute, just instance dot and then attribute name, it's going to run that function and return true or false based on whether it's true or false right now. Best practices, just really quickly, I'll get into a very few. When should I use classes? Use them to organize your data. So, like in this driver example and the person example, we have things that are related to person. The name, the birth year, eligible for a driver's license. These are all things that are about the person themselves. If we had something else like, well, I'll get into that a little bit later. But these are all things that are related to the person, the driver, things that are inherent to them. Use classes to preserve state for methods. So, we save the birth year in under init, and then when we run eligible, we're using self.birth year. So we're using that state here in eligible. And remember, we also have under string, and that also uses self.birth year. So we save the birth year state so that str and eligible can both use it. We save that state there. If we didn't have a class, if we didn't have an object, but instead we just had to do this with functions, we'd have to pass birth year in both times. But because we have the class, that class provides a place for us to store that so that we don't have to keep on telling the user of your API, you have to pass in birth year every single time. No, you do it once, and then every time you use this instance, this user instance, you'll have it available. When not to use classes, when not to use inheritance. Well, one of the things I see people who come to Python from like Java or C++ or something else is that they use classes for namespaces. They say, okay, well, I have all these functions. They're kind of related to driver, like go down the highway, or buy a new car, these things. These are kind of related to driver, but you can kind of see, well, some of these things are like, it should take a driver object and it should take a highway object in order to do things, right? It should probably not be a method of the driver class itself because it's not inherent to the driver. But people who are used to languages where they don't have native namespaces will say, okay, well, I don't want my drive on highway to conflict with a library that might have a drive on highway function. So I'll create a class. I'll stick this inside of there. It will namespace it because you can't access it without the class. In Python, we do have namespaces, though. All you have to do is create a file. So if I have a driver.py file, I can stick all my driver things in there. And if I have a highway.py file, I can stick all my highway things in there. And that way, it won't conflict with other libraries and other things that have been installed in Python. It will do that namespacing for you. Don't use a class for that. It's not needed. Inheritance, I'm going to warn you, I showed you inheritance, but inheritance has a lot of cases where it's not the best thing to use. It's because inheritance has all these things about it that when object-oriented programming was first designed weren't obvious, but have over the course of 30, 40 years of use have become obvious to people. These are problems with inheritance. But one very cut and dry rule is if you have a has a relationship, don't use inheritance. So going back to the driver class, yeah, a driver has a car, right? I was talking about maybe you need a car in order to tell about driving down the highway. Well, a driver can have a car, but it shouldn't be a car. It's not an is a relationship. A driver is not a car, but a driver has a car. So don't use inheritance. Don't say driver should inherit from person and car. Instead say, oh, driver has a car, so I'm going to pass a car into my initialization function. That's going to be the car that the driver uses. And you save that as an instance attribute on your instance of your class, right? So that's has-a. Use attributes rather than inheritance. Sometimes use inheritance when you have an is-a relationship. So driver is a person, so we used inheritance there. But not always, and this has to do with there are problems with inheritance that weren't obvious from the get-go. And I'm not going to get into all the problems you can run into, but I'm just going to mention, look into the list-off substitution principle. Make sure you understand that before you're using inheritance, because that really lays the groundwork for everything else. If you can substitute your child class for any place where you used your parent class, then you are obeying the list-off substitution principle, and that's a good sign that the inheritance is okay. But if you can't, then that is a sign that you should not be using inheritance to solve this problem. I'll just leave you with this slide here, which tells you other places where you can look for some of the advanced features that I mentioned, special methods, useful decorates, inheritance. I will make sure that the link to these slides is posted in the YouTube channel and in the calendar invite. So if you want to look at these advanced these links later, you'll be able to do so. All right. Any questions? All right, great. I hope that wasn't either too basic or too advanced for all of you. There's a ton more things that we can talk about with classes. If you want a second talk on classes sometime later, go ahead and ping me and say, let's talk in depth about this thing, and I'll try and write a talk for it. Yeah. I will stop recording now.